Go.
Good afternoon, everyone, respected subject teacher and my beloved friends. Today we are here to present about the topic function. It's me, Apreksha Bandari.
It's me, Vidhika Vande.
And Angela Lamisani.
Now I request Vidhika to start our presentation.
Thank you. Function is a special mapping or a special relation, or it is also called mapping. And if we have to move into its definition, then function is defined if let A and B be the two non-empty sets, then the function from A to B is a special relation or a rule, which associates each elements of A to unique elements of B. And let us suppose examples. So here are some examples of function, and this is not a function because elements of C is not associated with unique elements of C, element in set B, so it is not a function. And here it is also not a function because elements of set A is associated with more than two elements in set B, so it is not a function. And there are many different ways to represent a function, and they are mapping diagram, set of order pairs, by tabular form, by graph, and by input-output machines. And if we have to move into domain and range of the function, then domain, let f is such that a to b is a function, then the first set A is the domain of the function and second set B is the range of the function. And there are three different types of function, and they are onto function, which is also said to be a surjective function, and one-to-one function, which is called injective function. Injective function. Oh my god. Injective function, and another is one-to-one onto function, which is also called bisective function. And now the function is said to be onto function if every element of set B has at least one premise in set A. So here is examples of onto function. So here every element of set B has at least one premise in set A, so it is called onto function. And the function is said to be one-to-one function if every distinct elements of set A has at least distinct elements of set A has distinct images in set B. So examples. So distinct elements of set A have distinct elements in set B, images in set B, and the function is said to be one-to-one onto function. If the function is both onto function and one-to-one function, then it is called one-to-one onto function, which is also called bisective function. And example. Here this function, this function is bisected function as it is both onto and one-to-one function. So thank you. My part is over now. I would like to call Angela Lamington.
Thank you. I would like to talk about, first of all, I would like to talk about inverse image and inverse function. So let me draw the element set A and set B. And the element of set A is x and the element of set B is y, having the function f, and y is the image of the x, so it can also be written as the function of x, and the relation between them is f inverse y is equals to x, which is known as the inverse image of y. And also for inverse function we have to draw one function here denoted by g, and to be noted, f is the function from set A to set B, and the g is the function from set B to set A. So f and g are in the inverse relation, and it can be denoted as f inverse equals to g. And now talking about real valued function, let f be the function, and if the elements of B are real valued or real numbers, the function can be known as real valued function. There are two types of real valued function: algebraic function and transcendental function. I will be talking about algebraic function. There are a lot of algebraic function. So introduce algebraic function. Functions having algebraic operation to define it are known as algebraic function. And in first of all, there is constant function in which it is defined by fx equals to c, where c is the constant. So let me write the condition first. And for second, fx is, or y, we can also write it y. Y is equals to x. It is known as the identity function. And in third, it is y equals to mx plus c, which is known as linear function, and it can be defined by this operation, algebraic operation, where m and c are the constant and x is the premise. And in fourth, there is quadratic function, where the condition is y equals to ax squared plus bx plus c, where a, b, c are the constant and x is the premise, and it is defined by this operation. And in C, y is equals to ax cubed plus bx squared plus cx plus d, where a, b, c, d are the constant, and it is known as cubic function, and x is the premise of the function. In number 6, it is polynomial function, where the condition is a n x to the power n plus a n minus 1 x to the power n minus 1, and so on. The number of n decreases until the value of n be the 0, and we get the answer a0, and x to the power 0 is 1, so we don't need to write it. And at last, there is rational function, where y is equals to px by qx, where p and q are the functions of the x, and the value of qx should not be 0. And now for the transcendental function, I would like to call my friend Aisha.
Now let us discuss about the transcendental functions. The functions other than the algebraic function are known as transcendental functions, which involve transcendental function involves trigonometric function, exponential function, and logarithmic function. A trigonometric Trigonometric functions are those functions which involve any of the six trigonometric ratios. For example, this is an example of trigonometric function. Its graph is now number 2 is exponential function. The function which is in the form of x equals to y equals to a to the power x, where a is not equals to 1, is known as exponential function. From this graph, we can see that the graph never intersects the x-axis. Thus, it always gives the positive value of y. So the range is always a positive real number, whereas it extends from negative x-axis all the way to the positive x-axis. So the domain includes all the real numbers. Now, for the logarithmic function, it is the inverse of exponential function, and it can be written as log ax. Now, from this graph, we can see that the domain of logarithmic function is always a positive real number, whereas the range includes all the real numbers. Now let us see some properties of log. These are some of the properties of log. Now let me solve a problem which includes a solve trick that everyone should know. From this property, we can see that if these numbers are in multiplication form, we can simply separate them by addition sign. But here the problem is they are not in multiplicative form, but they are separated by plus sign. The trick here is that 1, 2, and 3 are the numbers which give the same result when they are added or multiplied. So this can be written as log a6, which can be further written as log a1 plus 2.3. So now from this property, we can simply separate it in addition form. Now that's all about the transcendental function and logarithmic function. If you have any question, you can simply ask us. Otherwise, it's the end of our presentation. Thank you.